Today I'm going to be summarizing about the first topic in Physics 1, which is dimensional analysis. When we're talking about dimensions, they are quantities that can be measured in nature. These most prevalent ones in physics are as follows. The first is L, which stands for length. Another is M, for mass, and T for time. One important point to remember is that dimension is not unit. For example, the dimension of length can be measured in the units of kilometers, miles, parsec, etc. There are also rules when you are operating with dimensions. In addition, and subtraction, the terms that you are operating with need to have the same unit. And also, the two sides of any equation needs to have the same units. For example, 1 kilogram can be added with 2 kilograms and we get 3. Notice that you are adding 1 and 2 and they have the same units. And between the two sides of the equation, they all have the same units. Here is an example of checking the dimensions of an equation. You might be familiar with this linear motion equation, and we'll see this later in the course. X is position, which can have the unit of meter. V is velocity, which can have the unit of meters per second. And delta t is the change of time. It can have the unit of seconds. A is acceleration. It can have the unit of meters per second squared. We can compare the dimension of this equation by replacing the units with dimension. So meters is length, and x here is length too, and velocity is L over t, and we have time as t. A is L over t squared, and delta t squared here is just t squared. And these cancel out. Now we have L equals plus L plus L. We can conclude that this equation can be valid because all the terms have the same units. Here is an example problem that uses dimensional analysis. Suppose we are told that the acceleration a of a particle moving with a uniform speed v in a circle of radius r is proportional to some power of v and r. Write the simplest form of the equation for the acceleration. So we have three variables here: acceleration a, speed v, and radius r. And we also know that a is proportional to some power of v and r. We can write this down as a is proportional to v to the power of something. Let's call that m. And a is also proportional to some power of r. Let's call it n. We can write this as an equation. So we have a equals v to the power of m times r to the power of n. multiplied by a constant k. So k is a constant. Acceleration has the dimension of length over time squared, and speed has the dimension of length over time, and r has the dimension of length, while k has no units. We can find the value of m and n by making the two sides of the equation have the same dimensions. So we have L over t squared equals L over t to the power of m times L to the power of n. Now we get L to the power of n over this and that. Now we can compare the two sides of the equation. You see this term here, t, and here, and its exponents. We can conclude that 2 equals m. So we have m equals 2. And looking at the exponents of both L here, we see that 1 equals m plus n. And we know from the previous answer that m equals 2. So we get that n equals 1 minus 2 equals minus 1. Now we can conclude the equation of acceleration, because we know that m equals 2 and n is minus 1. And the answer is k v squared over r. Thank you very much for watching. If you have any suggestion, make sure to comment down below.